Well, hello everyone. I'm Tola Awofolu, and I'm going to be doing a talk about Spring Cloud. This is basically an intro-level discussion about Spring Cloud. So if you're new to Spring Cloud, you've come to the right place. The goal of this presentation is to give you a practical demonstration of how you can use some of the latest and greatest modules from the Spring Cloud ecosystem to develop cloud-native apps for today. So in the next hour, we're going to be live coding a simple real-life app using microservice patterns. So here's what the app looks like right now, and I'll show that to you right here. So here we've got what I'll call a voting dashboard, and it's basically a dashboard that aggregates data from two voting squads, a red voting squad and a blue voting squad. So it aggregates voting data from the red squad, voting data from the blue squad, it aggregates it together and displays it in a visualization. Now, as you can see here, there is no data right now powering this dashboard. What we're going to do is build the back-end microservices for this dashboard. So let's take a look at the architecture for our system, and I'll bring up a quick overview here. So we got our UI, and the UI is going to subscribe to a stream of events emitted by our gateway service, which will be our API gateway, or the entry point into the system. This API gateway service will route to either the blue service or the red service by matching on a set of predefined predicates. In turn, the blue and red services will invoke a random number generator API, and it will use that to generate random voting data for the app. It'll use Consul for service discovery, Spring Cloud Load Balancer for client-side load balancing, and Spring Cloud with Resilience4J for circuit breaking. Now, a quick overview of what those terms mean. Service discovery, and by extension, service registration, is one of the design patterns that are required in a distributed environment. And it's just an acknowledgement of the fact that you can't assume that you can locate services by their physical address, because you're dealing with a dynamic environment now where service addresses can change at any moment's notice. So instead, you rely on some kind of virtualized addressing scheme to locate services. This virtualized addressing scheme, or logical addressing scheme, will then be responsible for translating between the logical address and the actual physical address of the service. With service discovery, services are registered in a service registry, which can then be queried later for locating their network addresses. You also got client-side load balancing, and if you take a look at the prefix LB here, that protocol tells API Gateway to use a load balancing enabled client to access the service. So it usually works with service discovery, and it allows load balancing decisions to be made on the client side and not just on the server side. There's several benefits to this. It eliminates single point of failure with server-side load balancers. It's easier to tailor load balancing decisions to the client, easier to automate dynamic changes at runtime, reduced network hops, and so on. You also got the API gateway pattern, and the API gateway is the entry point for your system, kind of like the front door of a building with multiple rooms. So it decouples the underlying microservices and their architecture from the outside world. And it can be used to consolidate cross-cutting concerns like security policy, access policy, content validation, traffic management, monitoring, metrics, and so on. You also have the circuit breaker pattern for fault tolerance and resilience. And there are several other resilience patterns like retry, time limiting, rate limiting, bulkheading. But here we're going to focus on circuit breaking. And with circuit breaking, services are wrapped in a monitor. When service calls fail, they're automatically redirected to a fallback API for a pre-configured window of time or a pre-configured number of calls. After this sliding window passes, if the service is healed, then its state is restored to normal. Otherwise, it continues to be redirected to the fallback. You also got other patterns: distributed tracing, centralized configuration, intelligent routing, distributed messaging, and so on and so on. So we'll be live coding our system to support some of these patterns during the course of this hour. So now let's go ahead and get started. So the first thing we want to do is we want to start up our console server for service discovery. So we want to start our console agent in server mode, so server true. We want it to be a bootstrap server, so bootstrap true. We want to start up our console UI. We want to be able to connect to the agent from anywhere. I'm going to bind it to my private IP here. I'm going to link it to this temp directory for console configuration. And with that, we should be able to start it up in the background. So let's go ahead and verify that, and looks good. So let's go to our browser and launch the console UI from there. And we can see that the console service registered itself here and the console UI is up and running. So it looks good. So next, we're gonna go ahead and create our red microservice. That's gonna be the service that handles generating voting data for the red voting squad and sending that to our dashboard UI. So to do that, let's go to the Spring Initializer website. It's start.spring.io. Let's create our app. Let's say workshop. Let's call it a red service. Let's include all the dependencies we need. So we're going to need a dependency to allow us to communicate with the console discovery server. So let's incorporate the console discovery client. We're going to want to do reactive APIs. So let's include Spring Webflux. We're going to want to include the latest iteration of the Spring Cloud Load Balancer. So let's include that, and we're going to use that instead of ribbon. Let's include the actuator module so we can expose endpoints for gathering metrics and events. And let's include a couple of utilities. So we'll include Lombok for boilerplate code. We'll include the DevTools library for live reloads. And with that, we should be good to go. So let's generate our app and let's import it into our workspace. So import, and let's get our app. So cool. So next, we're going to leverage auto configuration here. So thanks to Spring Boot's auto configuration, we're going to be able to enable several core features without having to write a lot of code. Instead, just by virtue of having the right dependencies in the class path, which we just took care of, and by including the right properties in our config, we're going to be able to have Spring wire up different essential components and add it to the Spring context for us. So let's go ahead and make some changes to our application config. I'm going to use YAML. You don't have to use YAML, but I just like YAML, so we'll use YAML here. So let's give our application a name. So we'll say Spring application.name. Let's call it red service. We want to make sure that each instance of our server is uniquely identified by console. So we'll say spring.console discovery instance ID, and we'll give it a unique identifier. So we'll use the prefix that matches our application name. So just copy that. And for our suffix, we'll use a randomly generated token. So this Spring EL expression is just utilizing the random property source, and that's an implementation of the property source that uses as its underlying object the Java pseudo-random class, Java util random, and it basically generates random strings for you. So it's pretty nifty. We'll use dynamic ports so that we can easily stand up multiple instances of our service. So we'll say server.port is 0. We'll disable ribbon. So we'll say spring.ribbon enabled is false. We'll expose all of our actuator endpoints for now. So we'll say management.include HTTP endpoints. Will include all of our endpoints. Obviously, in real life, you're going to want to use some access control for accessing these endpoints, and you're not going to want to expose all of them. But for our purposes, it's fine. And with that, we should be ready to fire up our red service. So let's go ahead and do that. Great, so our red service is started. So let's go to our browser again. And we can see that the red service registered itself. So that's good. And let's actually start up another instance of our red service. Once we do that, that should also register itself and we should see it in console. So indeed, we see that there are now 2 instances of our red service with dynamically allocated ports. So wonderful, that's great. So let's stop that second instance for now. Next, we're going to write some code, and what we want to do is leverage the discovery client, which is automatically wired up for us via the discovery client dependency that we've injected into the class path. So what we want to do is we want to write an API that will leverage the discovery client and use it to locate all the available service instances. So let's create a controller, and we will create a REST controller. Let's create a controller class here. And let's go ahead and inject our discovery client. So we'll say auto-wired discovery client. And let's create our API. So we'll say we want to return all of the instances, and we're gonna, in order to do that, we're gonna return discovery client dot get all the services. So first we're gonna get all the available services. Then let's stream that. So let's stream. Then let's do a map, and we're going to map each service that we locate here to all of the instances associated with that service. So we're going to say discovery client dot get instances, and then we're going to apply our mutable reduction and collect all of those instances into a list. So we'll say collect, and we'll say collectors to list. So that looks fair. So let's register that API. So we'll make it a get resource. So we'll say get mapping, and the path will just be instances. So that looks good. So let's go back to our browser. And if we go to our red service, we see that it's been allocated port 53128. So let's go to localhost 53128/instances. And we can see that we've got some data coming back for each of our instances. And actually, we should go to Firefox for this because Firefox has a nice JSON viewer. So let's go to Firefox. And let's locate. And now you can see the services and all of the instances. We have our red service and it's prefixed with the app name and suffixed with our random token. So that looks good. So next, what we should do is we should write the logic for generating random data. So let's create a separate microservice that will actually generate random numbers. For that, we'll go back to Spring Initializer. Let's create another app. Let's call it Vote Generator. And we can use the same dependencies that we just used for the red service. So let's generate that. And let's go ahead and import that into our workspace. So import Vote Generator. Great. So now let's go ahead and make some of the same config changes that we made for our red service. So let's give our app a name and let's call it Vote Generator. Let's make sure that Consul is able to uniquely identify service instances. So we'll say Spring Consul Discovery Instance ID, and we'll give it the application name as the suffix and the random token as the, or I should say the app name is the prefix and the random value is the suffix. Let's disable ribbon. So we'll say Spring ribbon enabled is false. Let's use dynamic ports. So we'll say server.port is 0. Let's expose the actuator endpoints for HTTP. So we'll say management.include HTTP or web exposure is, we'll expose all of them for now. And let's go ahead and fire that up. So now it's started up. So let's go to our browser. And indeed, we see the vote generator has registered itself. So that looks good. Now let's go ahead and create the API, which will generate random numbers. So let's create a controller. So we'll say vote generator controller. Let's have a random instance variable. So we'll say random equals new random. And now let's go ahead and create our API. So we're going to use a flux as our output. And for those who might not be familiar, Flux is just an abstraction that was an implementation of the publisher interface from the reactive stream specification. So it's a stream of data that's generated by a producer and subscribed to by a consumer. So let us go ahead and set up a flux of integers, and we'll say get random numbers, and we'll have it return, let's have it return a random number every 3 seconds. So we'll say flux.interval, we'll say duration dot of seconds, and it'll be 3 seconds. And then we'll say, we'll do a map. So let's do a map. And for each emitted event, we're going to generate a random number. So we'll say random dot next and we'll set the bound to 100 so that our random numbers will be between 0 and 100. So that looks good. So let's register that. So we'll say get mapping, and our path is going to be random numbers. And our content type, which we'll use produces to specify, is going to be something called text event stream. And if you're not familiar, text event stream is the content type for server-side events. And server-side events is a protocol that lets the server push events or data to a client over an HTTP connection. So kind of like WebSockets, except that it's unidirectional. It's just the server pushing events to the client and not the other way around. And also, there's no need for upgrading the HTTP protocol to enable it. It just uses the plain HTTP protocol. So it's pretty nice. So we're going to leverage that here. And with that, we should be good to go. So let's go ahead and fire up our vote generator, or it looks like it's already fired up, which is great. So let's go back to console and let's check out the port. It's port 53813. So let's go ahead and navigate to port 53813 / random numbers. And you can see every 3 seconds we're emitting a random integer. So great, that looks good. So now we should be able to leverage this random number generator in our RED service. What we want to do is we want to use the web client, which is the reactive HTTP client from Spring Webflux, to invoke the random number generator. So that's going to be our downstream service. And we want to configure the web client to use client-side load balancing. So every request by the web client will be intercepted by a load balancing filter, which knows how to use a load balancing strategy to load balance between available instances. So let's go ahead and configure our web client. So what we're going to do is we're going to create a config class where we will configure our web client. Let's mark it as a configuration class so that Spring knows to scan this for Spring Beans. And let's configure our web client. So we'll say web client builder, web client builder. We'll return web client builder, and let's go ahead and mark that as a bean and mark that as load balanced. Awesome. So now we should be able to auto wire the web client here. So let's say web client builder, web client builder. And also, before we create our API, let's have a wrapper class or DTO that's going to take the random number and wrap it in a class that will be presented with voting that will be presented to the front end with voting metadata. So let's create a vote class. It'll have a count member. It'll have a member for something that we'll just call a district. And it'll have an unavailable message that will be displayed when there's no voting data that's available. And let's take advantage of Lombok here. So we're going to use the data annotation to auto-generate getters and setters. And we're going to use the builder so that we can generate a builder for constructing vote objects. So awesome. Finally, in our voting metadata that we send to our front end, we're going to include a district, and just so that we have a good amount of cardinality with the district, we're going to make that a random token. So we'll use our random property source here, and we'll say string district. And now we should be able to register a new API. So what we'll do is we'll say we want a flux of votes, and we're gonna say get votes, and then we'll say we wanna basically return web client builder dot build. So we're gonna have a new immutable instance of the web client. Then we'll say dot get, we'll start a get request. Our URI is going to be the logical address of the service that we want to invoke. So we're going to invoke not the physical address, but a logical address. And in our case, it's going to be the name of the application that we're trying to interact with. So the name of our application is Vote Generator. And the path is random numbers. Good, so let's retrieve the response. Let's convert the body of the response to a flux, and it's going to be a flux of integers. And then let's go ahead and do a map here. So we'll say for each integer, we want to map it to a vote object. So we'll say for each integer, and that's going to be the count, we're going to say vote new vote builder. We're going to utilize Lombok here. Vote builder. And then we'll say that our count is going to be just our count. Our district is just going to be our district. Our message is just going to be a blank string for now. And then we'll build that. And we should be good there. So now let's register that API. We'll use a get mapping again. Type is going to be, or the path is going to be votes. The content type produces is going to be media type text event stream. And we should be good. So now if we go to our red service, we see that it's been allocated on port 55028. So let's go to localhost 55028/votes. And we see that we're now returning data with the count, a district, and an unavailable message. So perfect, that looks good. Now what happens if our vote generator was to go down? Let's go ahead and kill our vote generator to see what happens. So Let's go back to our browser. And what actually happened here was that it errored out. And this is an example of cascading failure where the downstream service causes a bubble up effect, and now it crashed our red service. So we don't want that. What we want is a more graceful way of handling when the downstream service, in this case, the random number generator, might fail. Instead of what we see here, we would like to have a zero count maybe. Maybe we can have our red service generate a zero count when there is that kind of failure. So that would be a more graceful way of handling the downstream failure. And for that, we're going to use circuit breakers. So we're going to use the Resilience4J implementation of circuit breakers. I do happen to have here the dependencies that we need. So I'm just going to add that to our POM file. And we're going to add that to our POM file here. And that's wonderful. So now let's go to our API and let us mark it with the circuit breaker annotation. It's very easy to enable circuit breakers. So all we got to do is specify the circuit breaker, and we need to specify a fallback method. So let's create a fallback method. We're about to implement that in a moment. And let's specify the name of the circuit breaker, and we'll just use the default one here. So let's implement the fallback method. We're going to have a flux of votes. And it's going to be the exact same name we specified here. And we're going to have it return a vote with just one count or a zero count. So we'll say flux.just, and we're going to say vote, new vote builder, and then we'll say count is 0, district is district, and we'll specify an available message in this case. So we'll say our data is no data available, and then we'll build it. We'll register our API. We'll say get mapping. We'll say our path is empty vote. Our content type is media type. The text event stream. And one more thing here, let's have the signature of our method. Oops. It needs to include exception in the signature. So now that we've got that, we should be able to test this all over again. So now what I'm going to do is I'm going to restart the vote generator. So we'll restart the vote generator. And then we'll restart our red service. And then we'll go to our browser. We'll go here. And our red service has been allocated 56639. So let's go to 56639. And we see that it's returning data. Now, when we stop the vote generator app, let's see what happens. So this time it just fails gracefully, or it handles the failure gracefully. It just returns a 0 count, and it shows an unavailable message that there is no data available. So that's perfect. So now we've got just 2 more microservices to build. The blue microservice, which is going to be similar to the red microservice, capturing and generating voting data for the blue voting squad to send to the UI. And we're also going to build our API gateway, which is going to be the reverse proxy layer responsible for routing to the microservices we built. So we're going to do that for the rest of the hour. So let's go ahead and fast forward through that. Okay, so now we've built our blue microservice, pretty similar to our red microservice, so nothing new there. We also built our gateway app, our API gateway app, and so let's take a quick look at that. We are using Spring Cloud Gateway for this, so we introduced a couple of new dependencies. We introduced a starter for Spring Cloud Gateway, and we also included a starter for the Resilience4J circuit breaker. In terms of configuration, most of the YAML file is familiar, is what we've already done. So let's just focus on what's new here. We enabled service discovery for our API gateway. We enabled cores so that our front-end app would be able to handle cross-domain access for our API gateway application. And we also configured route definitions. And this is the meat of Spring Cloud Gateway. Each route definition consists of 4 basic elements. You have the unique identifier, so here the ID is red. We have our URI, which tells the gateway where to route to. So in this case, it's going to route to the red service. We have our predicates, which are a set of Boolean expressions telling the gateway what needs to match in the request. So in this case, the path should match this pattern here. And we have a set of filters, which are just a set of interceptors that need to be applied to the request or response once there is a match. So in this case, we have the rewrite path filter, which will strip out the red prefix from the path that we invoke for the downstream service. And we have the circuit breaker, which we have already kind of covered before. So we're invoking a circuit breaker, we're giving it an arbitrary name, and we're defining a fallback URI here, which we've defined in code. And by the way, you don't need to define your routes in YAML. You could also define it in code. We just defined it in YAML for our purposes. So here's that fallback URI. And we basically use Spring Web Flux for that. So that's not new. And we also created a customized configuration for our circuit breaker. We use the customizer interface, which is new in Spring 5. And we did that because we needed to change the timeout for the circuit breaker. By default, the timeout is 1 second, but the interval for our data generator is 3 seconds. So we needed to bump that up. So I bumped it up to 5 seconds. So now that we've got that, our microservices are all up and running. So now let's go to our browser. And indeed, you can see that our app is happily collecting data from the red voting squad and the blue voting squad. And here's the data that it's capturing. So all is good with the world. And if we went ahead and killed one of those services, so let's say we killed the blue microservice, and we go back to our browser, we see that it's essentially handled gracefully. The blue microservice just returns an empty hash, and the red microservice is still working as it should. So the blue microservice hit the circuit breaker that we implemented. And happily, we can restart the blue service and it should be restored to normal. So there's a bit of a wait period for it to pick it up. But after that wait period, we should see that it is restored back to its normal state. So let's wait for a little bit here. And indeed, now it's all back to normal. So thanks again. I hope this was a helpful introduction to Spring Cloud for you, and hope to see you next time.